Hello everyone and welcome to day 2 of similar polygons and triangles. To start off, we've got a definition for similar figures. So these are shapes that are proportionally the same. So essentially they're the same shape, but they're different sizes. The scale factor is the number that you would multiply each part by to increase or decrease in size. So we mark similarity with this little squiggle line. So in this shape, we're told that ABCD is similar to EFGH. To identify similar polygons, I'm going to compare the proportions of the corresponding parts. Really, I'm just making sure that the proportions are the same. So in my first shape, ABCD, I'm going to look at side AB. Side AB is corresponding or in the same place as FE on my smaller shape. So I'm going to make that my first proportion. That proportion, AB over FE, has to be equal to a second proportion, which will be from two other corresponding sides. I'm going to look at BC and FG, for example. So those have to be the same, which has to be the same as every other proportion. So I'm going to label these all out. CD over GH has to be the same as my last one, which is AD and EH. AD over EH. Notice how all of my top numbers or top letters are from one shape. These are all from ABCD, which is my first shape, the big one. Whereas all the bottom letters, FE, FG, GH, EH, those are all from my other shape, which was EFGH. So I just need to make sure that I'm staying consistent. If I choose to have I chose that position when I put AB on top of the first part. So I had to stay consistent through the whole way. Okay, let's do some examples. First example, I'm going to list all of the pairs of congruent angles. Since these shapes are similar, their angles are congruent. So I'm going to write that up here. Similar shapes have congruent angles. Yay! So I'm going to start out by listing all my congruent angles. Angle A here, angle A, is corresponding to angle E, so those are congruent. My next one, angle B, we'll put 2 with the angle B, is corresponding to angle D, so angle B is congruent to angle D. And last one, angle C is corresponding to angle F, so angle C is congruent to angle F. Now, since these are similar shapes, they don't have any congruent sides, but they do have corresponding sides that are proportionally the same as every other corresponding side. So I'm going to write out some proportions. My first proportion is going to be with AB. AB, and I'm going to put it over the corresponding side from my second shape, which is ED. So ED. And that has to be equal to a second proportion. I'll do BC over DF, which has to be equal to a third proportion, which will be AC over EF. For number 2, I need to determine if these figures are similar. I'm going to do that by comparing the proportions of my shapes and making sure that they're the same. So let's start out by finding my proportions. I'm going to look first at XY and QR, which are corresponding sides. So the proportion of XY over QR is equal to XY, which is 6, over QR, which is 4. This fraction can be reduced to 3 over 2. So that's my proportion. And now we do it again. check YZ and RS. So it'll be YZ over RS, which is 9 over 6, which reduces again to 3 over 2. And I'll do it again. YZ and PS, or WZ over PS is equal to 12 over 8, which again reduces to 3 over 2. So far, so good. They're all the same proportion. If the last one is the same, then I know that they are similar. So that would be XW and P, or QP. So XW over QP is equal to 15 over 10, which again reduces to 3 over 2. So all of my proportions were the same. They're all 3 over 2, which means these are similar. So I'm going to write a similarity statement. X, Y, or W, X, Y, Z, I'm going to put it in order, is similar to P, Q, R, S. Okay. Number 3, we're told that these polygons are similar and we need to find the variables of x and y. So my x variable is right here, which is talking about this side. This side is proportional to, on the smaller triangle, the side that's 4. Those are proportionally the same. So let's write those as a proportion. X over 4 is my proportion. I took x from the big triangle and put it over 4 from the small triangle. Now I need to equal that to a second proportion from the triangles because I'm told that they're similar, so their proportions are the same, and use that to help me find x. My second proportion should not have any other variables in it, so I need to find 2 corresponding sides that already have numbers. I'm looking at these two, 6 and 10. So I took x from my big triangle, so I need to take 10 also from my big triangle and put that on top. And on the bottom, I'm going to put 6, which is from my small triangle. I am going to first reduce that proportion, 10 over 6. This reduces by 2 on the top and the bottom. So my new proportion before I start solving will be x over 4 is equal to 5 over 3. To get rid of the 4 at the bottom, I'm going to multiply by 4. And that will cancel out that 4. And whatever I do to the left side, I have to do to the right side, so I'm going to multiply that by 4 as well. Now, 4 times 5 is 20. So I get 20 over 3 is equal to x, which is all alone. So x is 20 over 3. Now I need to do it again for y. My y is this side, which is corresponding to 5. So my proportion will be y over 5. Again, I'll make that equal to my other proportion that I now know, which is 5 over 3. Just took it from the first problem. I'm going to multiply by 5 on both sides to get rid of the 5 underneath that y. So I get y equals 5 times 5, which is 25 over 3. So 25 over 3. Try to have the variable on the top of your proportion if you can. It'll make it a little bit easier. Number 4, a couple things I want to notice is that on my first shape, I have 2 sides that are the same, and they're across from each other. They're both 12. Since I have one pair of congruent sides on that first shape, that means I have another pair of congruent sides on my second shape, which will be these 2. So those 2 are the same. And these 2 should also be the same because it's the same shape, just bigger. So if that top side is 16, then my bottom side also has to be 16. So y is 16. And now we need to make a second proportion for x. So my x is right here. I'm going to put that on the top of my proportion. And on the bottom, I'm going to put 18, which is equal to a second proportion that I need to both have numbers. So I took x from my smaller shape, so I'm going to take a number from my smaller shape. I'm going to take 12 over the corresponding side, which was 16. First thing before I start multiplying, I'm going to reduce this fraction. They are both divisible by 4. So when I do that, I end up with x equals 18. I'm going to draw an arrow saying I went this way. Equals 3 over 4. Now I'm going to multiply by 18 on both sides. So those 18s go away, and I get x is equal to 3 times 18, which is 54 over 4, which reduces to 27 over 2. Let's look at our next theorem. Similar polygon and perimeter theorem. This theorem says that if two polygons are similar, then their perimeters are proportional to the scale factor between them. Basically saying that the perimeter proportions are the same as every other proportion. Cool. So for number 5, given the following triangles, write all of the ratios of sides and perimeters. So let's start with writing out our proportions. We got AB and XY. So I'm going to do AB over XY, which simplifies to 9 over 3, which is 3. Now we do it again. BC and YZ. BC over YZ is equal to 6 over 2, which again simplifies to 3. And AC and XZ. AC over XZ is 12 over 4, which again simplifies to 3. So these are similar triangles. So let's find our scale factor. If I look at AB, AB is 9. So what number do I multiply by 9 to get 3? So that will be my scale factor. That's my scale factor. 9 times x, to get rid of that 9, I will divide by 9 on both sides. And I get x equals 3 over 9, which simplifies to 1 over 3. So my scale factor is 1 over 3. And my perimeter ratio is going to be the same as all of these other ratios, which were all 3. Okay, last one, number 6. We're told that these shapes are similar. Find the scale factor of ABCDE to PQRST and each polygon's perimeter. So the scale factor, I'm going to find by comparing two sides. I'm going to compare this side, CD, to RS, because they are corresponding to each other. So what number would I multiply 4 by, which was CD, to get me RS, which was 3? I would divide by 4 to get that number by itself, and I get x equals 3 over 4. So my scale factor is 3 over 4. To find the perimeter of ABCDE, I need to add up all of the sides, add up all sides. And I first need to find the measure of all sides. Well, AB is the same as BC, and AB is 8, so BC is also 8. And CD is the same as AE, and CD is 4, so AE is also 4. So my perimeter is going to be 8 plus 8 plus 4 plus 4 plus 6, which is 30. So 30 inches. Now remember, my perimeter is proportionally the same on both shapes, which means it has the same scale factor. So to find the perimeter of PQRST, I don't even need to add up those sides or find the measure of them. All I need to do is multiply my perimeter, 30, by my scale factor, which was 3/4. So when I do that, and remember every whole number is over 1, 30 times 3 is 90 over 4, which is 45 over 2. And so if you want to reduce that, you can, but I'm just going to leave it as an improper fraction. 45 over 2 inches. And I'm going to make that look more like a fraction really quick. Great. And I am done. So that's it for day 2. I'll see you all for day 3. Bye.